Dear learners, today we have the course on Vsat and DSB television. This is a part of the course of the process of satellite communication as mentioned in our postgraduate course, and after completing the multiple access technique, we will move towards the Vsat. So what Vsat is? If you look out the diagram, I think some of the elements are very familiar to you. Those the dish antennas, the networks, router, modem, and obviously the figure of the satellite. I think you have observed in the book and waves and different channels in your television, the Discovery, etc. So they make several programs on the satellite communications and related those matters. So, in this context, I may recall you that Vsat is nothing but a very small aperture terminal, which is a full form of Vsat. I think the first letters are mentioned in a different color so that you can identify it very clearly. So, it's a very small aperture terminal for small software-driven earth stations. And the small satellite dishes which are shown in the figure, they are capable of both transmitting and receiving the radio signals, as you may find out very clearly. So from the transmitting signal, this is connected with a high capacity internet link, and that's the subscribers Vsat this, and the transmitting is the service provider satellite hub connected to the geostationary satellite through uplink, and downlink will come to the subscriber Vsat this, and through the network connectivity, that means router and modem, it will go to the terminal PCs, that means the receiver's device. So that's the schematic diagram I have shown in the figure, and based on that I will mention some fundamental features of the Vsat. That is mostly designed in 6 by 4 gigahertz. I think you may recall our transponder class where we have shown the transponder design at the 6 by 4 gigahertz terminal, and it is also designed in the cross bands like 14 to 11 gigahertz. Now you may know that X band is from 8 to 12, and then you have to move for Ku band, which is 13 to 18, or say better 12 to 18. So the uplink and downlink frequencies can be set at different bands also. There is no problem. If you say C band, then it will be 4 to 8, and 6 by 4 gigahertz is precisely at the C band. But you can move on a different bands also, and 30-20 gigahertz, these frequency bands means it is K band to K band. So that's also another Vsat point. And the technology involves FDMA and TDMA. I think you may know the TDMA and FDMA techniques, which are already discussed in our earlier class of the multiple access technique, and that video is already available in my YouTube channel. So if you forget about, you may brush off your knowledge by going through the video, and the presentation is also uploaded in the SlideShare account, so you may look out at key points of the FDMA and TDMA. And these are generally used for reliable transmission of data, voice, video, etc. through the satellite. And data rate varies a wide range. Now you can access, or you can make a data rate of 16 Mbps, which is a very high data rate through Vsat. Normally started the journey from 4 kbps, and generally it set a limit up to 4 Mbps. Now people can move on 16 Mbps. So it's a very high data rate that is possible through Vsat. And now comes to the components of the Vsat. What are the different components? There are two major components, are transceiver and terminal devices. What is transceiver? That is placed outside with direct line of sight with the satellite. It's placed outside with direct line of sight with the satellite, and it receives or sends signals to the transponder. Receives means it through the downlink it receives, and sends means through the uplink it can send. So placed outside at the line of sight, that is one of the key aspects. Now please think line of sight. It's a very important terminology. That means the Earth's radius of curvature will play a very important role related with the line of sight communication. So I will go for the limitations and the applicability of Vsat a little bit later on, where this factor will come into a very important and a critical parameter, because line of sight communication is extremely crucial factor. And terminal devices are generally placed at indoors because your PCs, laptops are placed at indoors to interface the transceiver with end user communication. So that's the terminal devices. So these are the two major components that are required to for the classification of the VSAT. So again, I am making it transceiver means you are going for transmitter and receiver. Those the two dish antennas I have shown in the previous slide, the block diagram, where you will get both the things as well as the signal to the transponder. Is basically it is a communication with the transponder to antenna through uplink and downlink. That's all. And terminal devices is your laptops and the PCs, the tablets you are using as your home devices. So that's the basic components of the VSAT. So the question, once I am going to the router and modem and the subscribers network related parameters, then a very important factor is the working of the hub. So how hub works? The Every end user that is interconnected with hub via satellite through some star topology, or it may be through some mesh topology also. So basically hub controls the entire network operation. You may ask a question how basically hub controls, and for that purpose I am drawing a diagram for you where you will find the local IP addresses, and that's going to your dish antenna. So I am setting at 1412 sort of dish antenna. So it goes through the uplink, goes to the satellite, and once satellite it comes to the downlink, and then it will be sent to the your actual PC. So that's basically a very simple feature. Actually the hub works. So I think you are basically accustomed with the router and modem and hub working principle. So I am giving a very simple schematic diagram which you can draw. You can understand it very easily. I am giving a data that's available from a web source. I have given the reference of the web source in the last slide of the lecture material. So you can click and browse. There are several links available. So there is no problem understanding the hub's operating principle. Now, I am coming to these topologies. Though I have mentioned star topology, but there is also mesh topology, and the combination is also available. So for that, let me go to the topologies a little bit more details. First, I am starting with the star topology. So what is star topology? That means hub will be connected with the VSAT via a duplex network, but the different VSATs, you can't correlate between themselves. So hub will be the central. If one VSAT terminal has to be connected with the another VSAT terminal, it should be connected through hub. That's the main configuration or the architecture behind the star topology. So all the communications occur through hub station. That should be a multi-hop communication. And naturally, since VSATs are not able to communicate between themselves, so it makes a higher propagation delay. But everything should be a central. Central is the hub, and every communication has to be made through the central point. So the smaller antenna sizes are enough because different vessels can communicate through a single transponder, and satellite can be communicated with the hub and so many things. So that's basically the star topology is. And it basically uses the TDMA technique. So star topology use TDMA technique, that is one of the most important factor, and high central hub investment, because the earlier investment at the time of incorporation of the hub, the investment will be much larger, but ideally suited for interactive data applications, because when you require all applications through the central processing unit or through the hub, then this type of interactive communications is facilitated by star topology. And large organizations like the demand it for centralized data processing requirements like bank. If you consider the transaction of a bank, it should go through a central hub. Otherwise, there will be a problem of the deadlock and several things, because you can withdraw money whatever your account consists of, because if it is not going through the hub, then every operation will not be reflected and there will be a problem. So any bank always require the star topology sort of things. And whatever the financial matters, everything requires the central hub. And it's classified into two types. One is called the shared hub, another is called a distributed hub. So let me go into slightly more details what is shared hub and what is distributed hub. In shared hub network, one large hub station is used and all the VSATs are divided into subnetworks. One large hub station is used and all the VSATs are divided into subnetworks. Each subnetwork is assigned to particular CUG. CUG means closed user group. Okay, and different CUGs is created for all the clients separately. So if you have more than one client, then you require more than one CUG. CUG to the client will be 1:1 mapping. That's the feature of the shared hub network. And each CUG will have their own inbound and outbound RF carriers. So they can have their own RF carriers, VSAT, and all the CUGs use the same one hub station. And please consider it is star topology. So one hub station is required. You can use your own RF carriers for inbound and outbound signals, but ultimately you have to communicate with the hub. Whereas in the distributed hub network, each network will have its own hub station known as mini hub, and this mini hub or min hub will be communicated with the central hub. So that's basically the distributed hub. Mini hubs can't communicate between themselves, but mini hubs have to be communicated with the central hub. The mini hub is located near the client premises, so to fetch the data. And in this network, all the clients will have its own traffic hub dedicated to its own CUG. So that will be much better compared to the shared hub network, because it works slightly faster. The propagation delay will be reduced compared to the shared hub network. And if I go to the mesh topology, then please think the VSATs can directly communicate between themselves. There is no requirement of the hub. So actually your manufacturing cost will be reduced. If you remove the hub from the Vsat network, then Vsat can directly communicate between themselves, and that is called mesh. So central hub is not required, and this is called point-to-point configurations. In this configuration, earth stations can communicate directly via satellite and will have only one hub communication. So there is one major difference between star topology and mesh topology. Star topology requires central hub, mesh topology doesn't require central hub. Star topology goes for multi-hub communication and mesh topology goes for single hub communication or one hub communication, whatever you may say. What are the features of the mesh topology? Naturally, the central hub is not required, so the propagation delay will be less, and it uses FDMA VSATs. So central hub investment you can cut down. So antenna size will naturally be larger, and it is suited for high data traffic and used for telephony applications. So there are several different sort of requirements, and for different requirements you have to go for different architectures. And some people go for combination of star and mesh topology because you have to minimize some overall cost and you are also to get the improved data communication facility. But I am not going into too much details of that architecture because our syllabus is confined in generally star and mesh topology, so I am confining our lecture within that. So what are the multiple access techniques in the Vsat? So we have used two types of multiple access techniques in general. One is called PAMA, another is called DAMA. So permanently assigned multiple access and demand assigned multiple access. In permanently assigned multiple access, every user is assigned a fixed channel irrespective of whether it is used or not. Please remind again, every user is assigned a fixed channel, whether you can use it or whether you don't use it. That is inefficient because channels are allotted to users even when there is no requirement, so channels sit idle. PMA protocols are considered the most effective techniques for those satellite networks with a small number of terminals. Basically, when you consider that all the channels will be simultaneously used at most of the time slots, then obviously you require dedicated channels for all the cases and you incorporate the PMA. And it is also called fixed assigned multiple access because you are fixing the channel, so it is also called FAMA. So it has the advantage of perfect for constant bit rate type sources. It's straightforward scheduler because you assign dedicated channels, and channel usage is contention free because you don't have to consider the interference between the two adjacent channels. Whereas if the disadvantage is the considerable bandwidth usage, you have allocated bandwidth for a particular user, whether it is used or not, and not flexible because while working with other terminals have variable bit rates, then it is not flexible. You are considering assuming that all data terminals have constant bit rate, so PAMA has that disadvantage. So in order to remove it, people going for DAMA, that is the demand assigned multiple access. So it is a protocol particularly used for Vsat systems which enables efficient and instantaneous assignment of transponder channels on a fast come fast serve basis. So basically it depends on the data priority. If you have more priority, then you will be assigned a channel. If you have less priority, you will be set aside and will be assigned later. So, typical Vsat systems, they use DMA for point of sale transactions. So, credit card, radio frequency or polling identification, the remote location internet access, the mobile maritime communications. For these cases, people use the demand assigned multiple access. So, these are some features. Basically, it is used for credit card. So, when you require the data, then you will be assigned to the channel. Now, what will be the characteristics of the VSAT systems? I will highlight here 7 very important characteristics. Please go one by one. First one is the reliable communication because it is error-free digital communication. Accuracy is 99.7%. Now it is 99.8% or more. And remote communication, this is remote diagnosis, remote monitoring, data streaming services, everything is possible. Network management, it is very easier network monitoring control. Deployment time takes very little, maybe 30 to 45 days. Maintenance, it's a single point contact for operation. Maintenance, fault isolation, troubleshooting, everything you have to consider single point. So there will be some SPOC for that and you can go for that. Cost is comparatively less compared with the leased line. That's why people going for VSAT. And flexibility, it is enormous expansion capacity in remote places. So where remote places you require some internet access, people always go for VSAT instead of leased line. And the advantages it brings severally directly to end user by reducing the hierarchical distribution network. That means it reduces the hierarchical cost. So that's the advantage, but it has some limitations. What are those limitations? A high initial cost for launching. Naturally, in geosynchronous orbit you require. So if you have the geosynchronous orbit, then this is not a limitation. But if you have to place or allocate a dedicated geosynchronous orbit, that cost will be incorporated and that time it will be much higher. And it requires clear line of sight between the dish and satellite. That's a major problem. Now, I have mentioned at the time beginning that Earth's radius of curvature. So you can't make a very large distance between them. Then the curvature of the Earth or unevenness of the Earth's surface can cause a damage of that. The latency will be higher, maybe more than 250 millisecond. Probability of damaging the antenna because the antenna is placed outside. And rain attenuation, that's a major factor. I have discussed about the satellite link design, the problems related with the rain attenuation, and rain attenuation can severely damage the VSAT performance. The uses of Vsat. So remote location access, it's possible. Interactive distance learning courses, receive internal communications, financial management, data processing, telemetry, virtual private network, everything is available in Vsat. Now I am going to the satellite communication. It's television programming that delivered to the satellite communication and received by the outdoor antenna. How it works? It is the data input, go to the Reed-Solomon encoder, then there is a interleaver, then 3 by 4 convolution and encoder. It goes to the convolutional decoder, de-interleaver and Reed-Solomon decoder. So that's the basically interleaver and de-interleaver process for a DSB TV or the satellite television. You have to go to the actually convolution encoder and Reed-Solomon encoder a little bit more details. Sorry for changing the slide. So how it works, uplink dish is pointed towards a specific satellite and uplink signal is transmitted within a frequency range. So the frequency range should be defined at first. Then signal received by transponder, it's sent to the satellite. One satellite send the downlink signal, again transponder receiving and resubmits to the Earth station. So it's basically the same procedure of the transponder which I have explained in my one of the previous lecture, which is available in my YouTube channel. And then the set-top box that demodulates and converts it to desired form. I think you have the set-top box in your home, so you know basically it's a DSB TV how it works. What are the features of it? Obviously, it is high definition. Everybody now getting the ad of the HD channels. So simple user interface. There is internal drive, the remote management is possible, digital video recording possible, detailed program information. You will get the program list. There will be keyword based search. You can use it, and there will be favorite list. You can save your favorite channel list. So that's one of the very important advantage of the satellite TV. And there will be some references, some web links. The Techpedia is a very good web reference, and the rfwireless.world.com, you can go there, you will get several details, and the textbooks, the famous two textbooks of John Williamson's, the Maini Agarwal and Pratt Bastian, you can refer them. Thank you all. This is a course on the Vsat and DSB TV. Next we will go to the satellite eclipse and other phenomenon parameters. Thank you.